out of the scene quickly, very, very quickly. So you have to be, so the point I'm trying to make is that when the technology is changing so rapidly, okay, and if you're not in a position to latch onto the bandwagon and actually adapt to the change, you go out of business very, very quickly. So that's why I say the risk is extinction, okay? That you adapt or you're gone. So in all this, the whole mindset is changing, right? Once I say the landscape is changing, previously we used to talk about systems, but that's no longer the case. It's not system that we talk about. We talk about platforms now. Platforms that provide various kinds of capabilities. The applications in the bygone eras were monolithic, but now we're talking about modular. Now, what exactly do I mean by modular? Something that's modular is that you can break it down into smaller pieces, and each one can work independently without impacting the other components in a system. A small example that I can give is, say, the fingers of a hand, right? The 5 fingers are there, but each one is modular. If one finger breaks, the other fingers do work, right? And compared to the same thing, if you extend the logic to other parts of your body, if you take the whole human body as a system, if one finger is not working, that doesn't mean that the other parts of the human body, like the head or the arms or the legs, don't work, right? That's a beautifully modular design that we have. So that's exactly what they want to extend to the computer systems as well. If one system, if you want to make a change, or if you want particular small application that you want to change, you should be able to do that without impacting anything else. And that's modular design, right? So let's go to silos now. Everything was actually, existing in its own world. Interaction and communication with other parts of the system was very, very difficult, even if it has to happen. It was cumbersome. But now, with the advent of APIs, things can happen as per the rules that have been laid out, right? Communication is very, very smooth. Everything was manual, but now we're talking about, automate everything. And we'll come to that in a bit. Previously, it was infrastructure, the part of an organization that was delivering servers or the networks or whatever. But now we are talking about as a service. We say we want infrastructure as a service, right? Whatever the customer wants, we should be able to deliver what they want, right? So that's as a service. If there are alerts, now we're talking about insights. If a system is going down, or if an application is going down, if it's an alert anywhere, that is only small piece of information that we have. But we want to have a deeper understanding about those alerts, why it's happening, when it's happening, and can we do something about it even before it happens? And let God forbid that it does happen, what can we do that can self-heal? That's insights, right? And we're that's related to this is predictive analysis, and that's part of machine learning, and we'll talk a little bit about that as well. And what's there with controls, right? We were saying that everything has to be controlled. Testers have to do this, developers have to do that, right? Infrastructure people cannot do this. But now we are saying we have to enable everybody. Everything must be self-service. We go by the rules that have been laid out, the policies that have been laid out, and we, whatever the tester has to do, they should be in a position to do it themselves by self-service applications. So we're enabling them, right? Everything was locked down, but now, everything is open, but trusted, right? Open source is, the big game changer that way, right? So, and the big tussle that was always there between developers and operations, now we are saying we want to bring them together and call them DevOps. It's not Dev versus Ops, but both of them have to work together to make things happen. Any questions so far? Okay, let's continue then. All right. So, where were we about, say, 10, 15 years back, right? Now there was infrastructure and there was virtualization, and everything was happening within an organization. The data, the servers, the processing, was all within the ambit of organization. If you talk about small organizations or big organizations, they themselves have to maintain everything. Virtualization was one thing that was possible, but it's no longer the case. Now we have infrastructure as a, now in addition to server virtualization, we have infrastructure as a service and platform as a service. Now, what is infrastructure as a service? Correct. Now let's take Amazon Web Services or Azure, right? Now, whenever you want a machine, a Linux machine, or Windows machine, or whatever operating system that you want, right? You can just go order it with the configuration that you want, with a particular CPU or with a particular memory, and it's been given to you. So that's infrastructure, right? Along with the network and the storage or whatever you want, right? So that's the main thing, that the companies are, because everything else is on top of that. So that's infrastructure. But the story doesn't stop there. With the VM, okay, once a virtual machine has been given, as a spun up and given, the story, that's only part of the story. Developers need a lot more than that. If a developer has to develop the code and deploy it, then this virtual machine, which has been delivered by IaaS or infrastructure as a service, has to have, all the libraries, all the runtime, everything, the code base, including the application code, has to be available and should be in an environment packaged very well that can run on its own, right? So that's what is platform as a service, that goes on top of infrastructure as a service, right? So in addition to the operating system, everything that an application needs to run, like runtime, even the application code, that has to be provided for the developers, so that the whole, the deployment life cycle can happen very, very quickly. Now, this is not just happening, within the private, within the confines of an organization. Now, these things can happen within the public providers as well, right? So these servers and this computing power, this network doesn't have to reside within your organization, but can reside elsewhere in the public domain, right? Where we have the public service providers like AWS, Azure, Amazon, GCP, and all that. In addition to that, you have on top of that, at the higher end of the hierarchy, we have software as a service, where not just everything, the software, not just your code, the service, everything runs on the provider's premises. All the applications that we use by just typing an address on the browser, which don't have to download anything. Those are all examples of software as a service, right? So from private, we moved on to private and public, and then organizations are offering the whole thing as a platform, right? Now they're not just confined. Many organizations have hybrid systems where they provide private cloud as well as public cloud, and they offer all these services as a cloud platform. So that is a stage that we are at right now. I'll pause here for a minute. Any questions? Okay, let me continue. All right. So I spoke a little bit about platform as a service, right? There are many providers of platform as a service, but primarily let me talk about Openshift, right? Red Hat Openshift is a major platform as a service. Now, let me just give you an example of what I mean by platform as a service. Let's say that you have various applications, right? All these applications, say HTML or JavaScript, they have various runtimes that are needed, and all of them have a data access layer, and they run on application server. Now, if you want to make any change to the application server, okay, then all the things that are sitting on top of it, you will have to make sure that none of them are impacted by it. But there is a possibility that they might be impacted. So anything that you change to the application server, can have a potential impact on all the applications that are sitting on top of it. But what if you package the application server with your application that you have developed, whether it's HTML and JavaScript, right? That's what Openshift provides. The whole thing is provided as a package within a container, and these containers actually run independent of each other. So now if you want to make a change to the HTML code that you have developed, you can just go and make a change to that application itself without impacting any other applications, because they run independently of everything else within their own container space. So that's what is a container. Okay, a container is a packaged software that has application code as well as the operating system, including its runtime, all running independently of everything of anything else. Okay, so you have one container that can run your HTML application, the other container that can run your Java, some other application that runs some other service, and all of this can run independently of each other. And of course, they have to talk to each other. That's a given. Within the massive applications that we build. But the important thing to note here is that the whole design has become modular. And when I say modular, I mean micro. Okay, and so we call them microservices here. So each of them is a microservice. The application that was monolithic has now been broken down into smaller components, and each of them runs within its own space. So that's what Openshift provides for developers. It provides this whole platform, whether it's, they have various, runtimes that the developers need, whether it's Java, whether it's Perl, whether it's Python, Microsoft, anything, right? All these things can be packaged into containers and deployed into production. So that's what Openshift actually provides, and each one of them runs as a container. I will just stop here. Any questions?
Yeah, what's the difference between this Docker images, Docker containers, and this Red Hat OpenShift?
Okay, so you would require any application that you develop, right? Now you will have to deploy it into a container, right? So before you do that, you need to have Docker, okay? So that becomes an image. The application that you have developed should become an image, and then that goes and sits into a container, okay? So Docker is what allows you to containerize an application. Okay, so Docker will allow you to put your application into a container, and above Docker you have Kubernetes. Okay, now Kubernetes is what orchestrates all these containers. Now some containers might require more resources than others, and you would want to have more replicas of some containers running at the same time, right? And you want to have a way of optimizing resources. Now, all these things are managed by Kubernetes, okay? Now, and sitting on top of that, which will provide a whole, management structure around all these things, is Openshift, okay? So you have Docker, okay, that will allow you to deploy applications into containers. And then you have Kubernetes that will allow you to orchestrate these containers depending upon the load, depending upon the resource management, and overseeing all these things above, the Docker and the containers is Openshift. Is that clear? Any questions?
Yeah, that's okay. Like, Red Hat itself, like using OpenShift, provide a similar thing, which provides by Docker. That means the management of this Docker containers is easy if I learn Red Hat OpenShift, right?
Absolutely right. Absolutely right. Actually, I did probably in the next session I'll plan for a demo how easy it is to actually deploy, container images using OpenShift, right? You can quickly Dockerize. So let's say you developed a .NET application, right? You use Docker to containerize it, the .NET application, and then you deploy this whole code into a container. And once you deploy this thing into a container, OpenShift takes over. Okay. Now you can set resource limits, quotas. Say if you have a small application that doesn't require, say, a lot of memory, a lot of CPU, and you can set that. But you say, at some point of time, I would want to have more of my replicas running, not just one application, but exactly the same thing I want to run in different availability zone, right? You have a data center and you have different data centers, and you want to run one container in one data center and another in a different data center, or you want to have more than that. But some other applications you don't want to allocate that much resources, but you want to reduce the resources, or limit the resources that you want to have. So all these things can happen on OpenShift. And at some point of time, if any one of your containers is actually not working, OpenShift kicks in and actually does the self-healing and make sure that the application that has gone down is replaced instantly. Okay, because in the configuration, at the configuration level, you have set that I want to have so many replicas of my application running. Say you have set 4 replicas. At some point of time, one of the replicas has gone down. That's one of the containers, one of the data centers has gone down. OpenShift quickly recognizes that and actually takes that container down and replaces it with another. So all these things can happen within the OpenShift environment. Any question? Is that clear? Okay, let me continue. Okay, so Red Hat OpenShift is actually, being deployed quite a lot. Many big Fortune 500 companies are actually, delivering their applications using OpenShift. A few numbers have been given there because it becomes much more simple in the whole CI/CD pipeline, right? Developers can add webhooks to their GitLab or whatever repository that you have, and as soon as a change happens, that you make a change to your application, you can set the process in such a way that it's automatically deployed. So most of the people that were in between, that were actually running the show, like taking the code from your repository and deploying it, making sure that everything is okay in production. So all those things can be eliminated. The monitoring has been refined, where OpenShift brings in the self-healing capability, resource management capability, and optimization capability. So all these things combined are actually allowing companies to save a lot of money. So some numbers have been given there. So to just to give you a glimpse of what OpenShift is offering. Okay, so why OpenShift, right? Now that's because OpenShift runs on the Linux hosts, right? And it's very trusted, combined with SC Linux, right? The trusted kernel. The content is trusted. All the images that you want to use have actually been scanned and verified by Red Hat themselves. Your application, whatever application, the code that you want to run, has to run on a base image, whether it's .NET or Java or Perl or Python. All these images are scanned and updated and made sure that they're clean to be used. And whenever it's required, updates are available. Red Hat Satellite is an application that makes sure that the patching and licensing and the updates happen whenever it's needed. And of course, it's very trusted. Okay. So now, let's just talk a little bit about, we spoke about, containers, we spoke about OpenShift, right? Let's talk, how do we manage this cloud journey? Because if you want to accelerate the whole thing, you should understand how you can, do this at scale. As the scale increases, the complexity also increases. At one end of the spectrum, right, you have, all these applications that provide various services. Red Hat OpenStack is an IaaS solution. OpenShift is platform as a service, and then you have, various uh, public cloud providers all offering this infrastructure, right? Now, once that's done, right, the other thing that you have to keep in mind is you'll have to make sure that uh, these softwares that you deploy, okay, can you have to make sure that they have the right patching, right updates, right licensing. Everything is taken care, because organizations do not have just one version of an application. They have multitude of versions of applications running at any point of time. Red Hat Insights will allow you to actually analyze the alerts and do some predictive analysis. So based on what has happened in the past, it might give you an indication of saying that if this and this and happens, something, this could also happen. So it allow you to take action before the incident happens itself. So that's what Insight brings to the table, right? And then if you have to actually take it to a scale where it's industrial strength, then you absolutely need automation. Okay, so Ansible is the automation engine that's a Red Hat product that allows you to automate most of the tasks that you want to do. If you want to deploy, if you want to upgrade, if you want to make any configuration changes, Ansible the Ansible engine will allow you to do that. All you need to do is see, these are the servers that will be impacted, and these are the changes that I want to do, to do, and this is in the order in which it has to happen. Ansible is very, very easy to learn. Okay, it's humanly readable, and it's quick to use and deploy. So Ansible will allow you to automate most of the tasks that you would want to accomplish in your OpenShift environment. And sitting on top of that is CloudForms, that will provide a single pane of view for all your cloud infrastructure. And a cloud infrastructure can have many components. It can have many providers, right? And it can have some IaaS components. It can have some PaaS components. It can have some virtualization, right? VMware, all that. All those things can be managed in one place, and CloudForms allows you to do that. Okay. So that's why it's important, right, to automate all these tasks. Okay, and that's where Ansible comes in. But why what is the need for automation, right? What exactly is the need for automation, right? Anything that's manual and repetitive should never be done manually. Okay, anything that's a repetitive task, you should look for an opportunity to automate it. Why? Now that's because as human beings, we are always error prone. Okay, and we are very, very inefficient. So you have to have an automation to take care of these manual tasks, so that we as human beings, people who are working, will have better things to do. Because if you don't automate, a lot of things might go haywire. Okay, so if you automate, what happens? What's the advantage that you have, right? You can focus your time on better things, right? You don't have to manually do a lot of things, right? You can eliminate human errors, and whatever you want to do, you can get it done in a much faster way and at a scalable speed. Okay, so it's actually, to serve the people, and it must be simple, right? So little bit on Ansible, right? It's picking up speed. It's tremendously popular right now. Most of the organizations are using Ansible, are leveraging Ansible, right? You can look at some of the numbers there. The number of stars they have on GitHub, right? The number of modules that are there in Ansible, and the number of downloads that are happening every month, right? So if you look at just this is the map from 2 years, you can see that how the interest in Ansible is growing, over a period of time, right, across the globe, right? But why Ansible? Of course, it's simple. It's very, as I said, the code almost looks like something that easy to understand, right? You say you deploy this thing, or you run a particular statement, or you say these are the servers that have to have make a change, right? So it doesn't require a lot of programming skills. Okay, and as I mentioned, you can order the tasks, the tasks which have to be executed, and all of them execute in the same order. And if one particular task is already done, it will skip it, and it will actually make sure it has the intelligence to understand which are the tasks that it needs to do, which are the tasks it doesn't need to do, right? And it will allow you to become productive very, very easily, right? A lot of things that can be accomplished using Ansible: application deployment, configuration management, workflow orchestration, network, okay, everything, life cycle. The most important thing is it's agentless. Most of the other configuration management tools and the the automation engines require a server as well as agents, but Ansible is agentless. You just need to have Ansible running on one of your servers, and you just set up on which of the servers it needs to run, and you specify the code, and that's it. From that server, it will just go and execute those changes or the deployments and all the servers. So it just runs from one central place without any agents that have to be installed on the destination servers. Okay, it's cross-platform, right? It has support for all major operating systems, physical, virtual. It's human readable, as I said, right? And it's version controlled, right? It has dynamic inventories. Okay, so a lot of advantages that you have by using Ansible. Okay, so I've already covered this, right? Various things. What are the things that you can do with Ansible? Configuration management, application deployment on various kind of components, load balancers, application storage, infrastructure. So it has the intelligence to deal with all these components that you deal with in your day-to-day life in an organization. Okay. So a lot of modules are available, for cloud, or for virtualization, for network. Even if you have to notify, everything, all those things are available, right? A lot of organizations are also using Ansible. Some of the just a few of the names that I'm showing here. But many of the organizations are taking advantage of Ansible and accelerating their whole application deployment and configuration. Okay, so that's the whole thing that I want to talk about with respect to Openshift and Ansible, and how we can accelerate the whole process before I go on to machine learning.
Okay, Srini, I have a question here.
Yeah. Yes, tell me.
Yeah, like I'm lagging a little bit, like a clarity on OpenShift, where exactly OpenShift is standing, whether it is useful for deploying machines, I mean, or will it manage the containers? So what exactly it will do? Or it is an alternative for Kubernetes?
Okay, no. Kubernetes will allow you to, manage your containers, right? Kubernetes is an orchestration engine.
It's a centralized management. Yes.
Yes, right.
Yeah.
Now, OpenShift, sits on top of Kubernetes as well as Docker. Okay, it will give you a UI through which you can manage everything, right? It will allow you to set, say, allow you to create projects, right? It will allow you to set permissions. It will allow you to set resource constraints. It will you to do quite a lot of other things that are not possible by using Kubernetes alone. Okay, say if you want to say deploy an application and you want to expose that as a URL, right? Now
Okay.
that can happen very, very quickly through OpenShift. Through a couple of clicks, that can happen. Okay. Now Kubernetes will allow you to manage those containers, but it doesn't allow you to do anything more than that. Okay. Say setting, say firewall rules, say setting, changing the ports, right? Or, setting the project permissions. So various other kinds of things that are, you would still need in order to manage your containerized application in an industrialized strength setup, OpenShift provides. Okay.
Okay. So here, it's like no application. I mean, no OpenShift application or client installed on Docker containers. Nothing like that. It's just maintain like I mean, a vSphere, like vCenter, which manages all the vCenter machines.
Yeah.
With
Yeah. vCenter allows you to manage your, your virtualized hosts, isn't it? Right?
yes,
Correct. So
yes.
this OpenShift is a lot more than that. Okay. Actually,
Okay,
it is much more, complex, much more profound. Okay. We're talking about, applications here. Okay. Making changes to applications, making changes to how the applications run, what kind of an environment that they have to run, right? So all those kinds of things
okay.
that you can manage through OpenShift.
Okay, so OpenShift is set up in such a way that we can do our operations in a container level and in application level, which are deployed in containers, right?
Absolutely right. That's correct.
Yeah. Oh, perfect. Yeah. Thank
That,
you.
that's correct. Okay. All right. I'll plan for a demo session the next time so that you can have a much a better understanding of OpenShift. Okay. So let's switch to machine learning right now. Okay. Do you guys have an understanding of what machine learning is? Okay. So let me just start, right? Now, what's happening is that there's a lot of information, that's being generated, okay? That's being floating around all of us, right? Because we have tremendous amount of devices at our disposal. The computing power is increasing enormously, right? And because of the social media and the ubiquitous nature of systems all around us, the amount of data that's being generated is actually humongous. Okay, it's unimaginable. Whatever the data that was, that's been there from the dawn of time until about 2005 is one story. But since 2005 and until now, the amount of data that we are generating is actually is something that's increased manifold. So when there is so much of data out there, right, there's also a lot of information that's hidden in it. But it's not possible for us humans to harness all this data. Okay, but machines are very, very good at that. Okay, now that's where machine learning comes in. Okay, some aspects of machine learning, we want to leverage because machines can do those things much better than we humans. But at the same time, we want to make machines do those tasks by themselves without any human intervention. Okay, so how can that happen? Because some of the tasks that are very difficult for human beings, machines can do very, very quickly, like analyzing a lot of data. But some tasks that are easy for human beings, machines find it extremely difficult. By machine, I mean systems, like computers, right? Let me take an example. So let's say there is a cat, okay? Now, when you see a cat, when a 2-year-old boy sees a cat, a 2-year-old person, boy or a girl sees a cat, right? He will understand, that what looks like a cat. And if you show him any other cat, whether it's a black cat or a brown cat or a white cat or a cat from some other country, young cat or an old cat, he would quickly say, yes, that's a cat and that's not a dog. Okay? But for computers to distinguish from one object to another, it's very, very difficult. But how can we teach computers to distinguish them, right? When a self-driving car is running on a road, it should be able to determine what's in front of it, whether it's a tree or a traffic signal or a human being. Only then will it be able to do things on its own. Okay, so how do we teach computers to actually identify these things that are very, very easy for us? Once we do that, then the software or the algorithms can take over and they can give us the results that we want. So let's, that one example that I gave, right? How do you allow a computer to distinguish between a cat and a dog, right? So what we do is we feed it a lot of images of a cat. Cats in various shapes, cats in various sizes, cats in various colors, right? What the machine learning algorithm will do is it will break down each of these pictures and identify the attributes. Now, what do I mean by attributes? Attributes mean the features that a cat has, right? It could be the length of its whiskers, it could be the ratio of its mouth to its eyes, it could be the size of its eye, whatever it is. Taking all these features, attributes of a cat, the machine learning system now has all the information that can, that it can say with a great degree of confidence that all these, features and attribute go and define to make a cat. So now, if you actually give it, after it has learned all these attributes, if you actually give it a different picture of a cat, which it has not seen before, because these attributes, even though, the attributes, do not, even though it's an image of a cat that is not seen before, these kinds of attributes do not change because ultimately we're dealing with a cat and not a dog. So the machine learning algorithm, depending upon all the data that is collected, will say that the image that I'm seeing has, this size of whiskers, this kind of facial features, this kind of, whatever hair or color, this size of face with respect to its rest of the body, and will be able to say with a great degree of certainty that this is a cat and not a dog. But remember, we are always talking, there are no certainties in life, and especially not in statistics. So it will set with a great degree of probability, say 99% or 98%. I'm 99% sure that the image that you have given me is that of a cat. Okay, so that's what machine learning is. Okay, just one example. Another example that I can give you of machine learning, right? So let's take the example of, say, I'm in the Bangalore city, and I want to know I have the information about the real estate prices here, correct? So now I know the cost of an apartment that's there in any one locality, and I give it, so what are the attributes that go to determine the cost of an apartment? I would just definitely say that it's the square footage, the number of bedrooms, the builder who has built it, right? The free space that's available. I can also talk about, whether it's which school district it is, how the roads are. All these factors go to determine the price of an apartment in a particular locality. A humongous number of attributes. Now, if I give it all this information of, say, in Bangalore city, I collect all this information and give it. The next time, if I ask the machine learning algorithm, can you give me the price of an apartment, say in Vadodara, that has this and this properties, right? It's very, very difficult for us humans to extrapolate the information that we have to the new problem that has been given and to come out with the price of an apartment in say Vadodara, right? But the machine learning algorithm can do that, right? So tremendous amount of applications that we are seeing by machine learning, right? Image processing is one example that I gave you, right? Real estate is one. Financial markets are finding a lot of uses of machine learning, right? Taking a lot of parameters into consideration and say, what might happen in the future given what has happened in the past. Military, tremendous amount of application, right? When when countries are actually scanning the enemy territory, they want to say what they're seeing is actually an enemy fire or it's something else. So you want to have the machine learning algorithms to help you do that, right? So in science, in medicine, tremendous amount of application in medicine, right? So a lot of uses that machine learning is being put to use to, right? And most of the software applications that are being developed do have machine learning modules running on top of them. But coming back to where PaaS fits in, right? Now, platform as a solution, especially Red Hat, why is it suitable for machine learning? Because when you're processing humongous amount of data, right, you require tremendous amount of processing power. You require resources to run. So, and the resource optimization and the workload management becomes critical. And that's where software such as Openshift will play a very, very important role. So Prodivance, the company that I work for, we have developed a machine learning platform, right? And that runs on PaaS. Let me just share a small video so that you can understand what I'm talking about. Okay, just give me a minute, please. Okay, let me share the video right now.
Prodivance brings you machine learning on platform as a service. There is a paradigm shift in the way businesses are building their technology stacks, moving into digital platforms and microservices. And how did this happen? All due to the cloud computing revolution. Cloud computing facilitates as a service business model. The coming years will see a rapid adoption of machine learning as a service. But why machine learning? Because data is the new oil. Organizations and consumers are generating lots of data. Machine learning is the future. As you can see the volume of data being generated each year, this data is a veritable gold mine. We need the power to convert this data into insight. Our analytics and AI approach. We transform the data into information, convert the information into insights, and translate insights into business values. Industries increasingly adopting machine learning. But machine learning solutions require specialized and often expensive hardware resources. They also need scalable computation power, access to machine learning models, security while processing and consuming data. Machine learning as a service industry is growing at 43% each year. The key drivers will still be resource optimization and utilization management. This is where Red Hat comes in. By leveraging containers and Kubernetes, Openshift abstracts the underlying infrastructure and provides robust capabilities to manage application lifecycle and development workflows. In addition, Red Hat OpenShift brings build and deployment automation, security, storage, networking, monitoring, and observability. The Protivant's machine learning platform is called iVentura, the data detective. Deployed on Red Hat OpenShift, it will enable data scientists to easily access and consume machine learning components. iVentura Workflow. This is the high-level architecture of iVentura. Key enablers of iVentura are Ansible for automation, CloudForms for chargebacks, KeyCloak for security, and KubeOps for monitoring. iVentura is well positioned to manage the complexity of machine learning, tight integration with Jupyter Hub and Dask, efficient workflow for data exploration using Notebook, flexible data storage options on RHEL, NFS cluster. Reach out to Protivants to know more about iVentura, the data detective. Visit www.protivants.com.
This is what I want to share.
Hello?
Hi. Okay, I'm coming back. Okay.
Yes, I have a question.
Yes, please.
Yeah, well, what about Terraform? What is Terraform used for?
Okay. Terraform is infrastructure as a code. Okay. Now, so let's say it's you have various cloud solutions out there, right? Whether it's Azure, Microsoft Azure, or AWS, or Google platform, even Red Hat products, right? You want a single tool to allow you to provision infrastructure and deploy it, right? One tool that can allow you to deploy, to work with many different vendors and actually provision infrastructure. So essentially you write code, okay? So, and that will allow you to bring and deploy infrastructure, not just one flavor of infrastructure, but many flavors of infrastructure cutting across different providers. That's what.
Okay, in what language is it? In YAML or what language?
1 second, I forget the name of the language that Terraform uses. 1 second, it's a pretty popular language. Okay, I played with it a couple of times, but I forget the language. Okay, it's not YAML, it's something else.
Okay, thank you.
Okay, so let's come back to this. Right now, I spoke a little bit about machine learning. Right now, we Protivants showcased this solution at a recent Red Hat event called Red Hat Forum, okay, in Bangalore, and we got a tremendous response. In fact, the stall where we showcased this machine learning solution on top of PaaS, got the maximum number of visitors, maximum number of registration. Okay, so how I showed you a little the video, that I played, right? I want to talk about a little bit about the architecture as well, right? Now, when you want to develop machine learning, write machine learning code, you require an IDE, right? Now, the IDE that's most widely used is called Jupyter Notebook. Okay, so on Jupyter Notebook, you write your code, whether it's Python or R, right? And you call various machine learning modules, and you leverage those modules using the data that you have, right? But when you're providing a platform, machine learning as a platform, it's not just one user. There'll be a lot of users that will be accessing this platform. So how do you enable that? Now, Jupyter Hub is another plugin that you can use, so that one user that's working on one application will have his own space to work on it, and after he is done, his code or whatever work will be saved into a persistent storage. And the next time that he comes in, now all the code that that he has worked on will come back. That's user authentication will happen through Keycloak, okay? And the Jupyter notebooks, sit on top of Jupyter Hub. And in addition to that, we have also integrated it with Dask, okay? Let me see. Okay, I don't have a Dask here. Okay, now what Dask does is it will allow you to run many parallel threads at the same time. Okay, machine learning, would require a lot of computation power, as I said, and where various users are running, code at the same time, you would want to have a lot of parallel processing to happen. So that's where Dask does it, right? And then you have storage. And enabling all these things, the setting up, it happens through the Ansible tower, and the CloudForm provides a single pane of view, so that all these things are available in one particular location. So the machine learning model was able to scale up, and the idea that we showcased was a facial recognition algorithm. That means users, come in and register at our booth, and the algorithm captures the face of the person who is registering. While exiting, the user comes back and actually just stands in front of the camera, and the algorithm actually recognizes that person and completes the whole process, right? So you bring up the properties that were saved, what the person is, what the age, what the company that he has worked for. But the most important thing is everything happens through the machine learning algorithm that runs in the background, and it recognizes persons and it ratifies people based on their facial features. Okay, so all these things was deployed on cloud and was showcased at the event. And so I just want to end this session by, I want you to take this away with you, that the platform as a service is great tool for developers, right? And it's a tremendous amount of it makes it easy for developers to develop their code and deploy, brings in a lot of security features, right? Makes the applications truly modular. And with Openshift, you have a way of optimizing resources. And when we're talking about optimizing resources, one of the greatest application that you will find is in machine learning, because machine learning is tremendously resource intensive. It's not just CPUs, but they talk about GPUs there. Okay, they require a lot of processing power. But platform as a service, especially OpenShift, Red Hat OpenShift, has that capacity to scale up to those demands of machine learning, and we've been successfully able to showcase this application during a recent event. Okay, so that's what I want to cover in this session. But in the next session, as some people are interested in learning more about OpenShift, I will do a quick, good demo of OpenShift as well. how developers can leverage OpenShift, how we can, deploy code, how you can manage the whole thing, and bring in some concept support nodes and everything as well. Okay. So any questions?
Hello. Yeah.
Yes. Yes.
Here, what is the data and how we are using that data?
What is, quick question?
Yeah, what is the data we are using, collecting, and what are the insights we are getting from this?
Data can come in many different forms, isn't it? Right?
Yeah.
It can come, say, through text files. It can come through, database. It can come through Excel, Excel sheets. It can come through social media, and data can be in forms of images as well. It can be in terms of voice, right? Voice as well,
Yeah.
right?
Yeah.
All
Yeah.
those
Understood.
data. Yes.
So here it is like, okay, you are providing the infrastructure for ML. That's it.
Yeah, we are providing.
Okay. I thought it's like for this PaaS you will like for cluster you will use ML so that you will detect. Uh, Maybe you will process. I thought it was like you will process logs of application as well as node logs. I thought it like this. Okay.
That's up to you how you want to do, right? We provide the machine learning platform. Using that platform, you can use it for whatever that you want. Okay.
Okay.
You want to analyze logs, you want to analyze financial data, image processing, whatever you want.
Okay.
Any questions? Guys, thanks a lot. Okay. I will do a follow-up session as well, and I will talk more about OpenShift. Okay. Thank you.
Thank you, Srini. Bye-bye.
That's it. Check it.